Wow. It's hard to wrap my head around the fact that it's been a whopping 7 months since my last Project Terminal devlog video. I know. I've been slacking a bit. Now, I must admit that there hasn't been enormous changes to the game, but that doesn't mean I don't have super exciting things I'd like to showcase. Without further ado, let's jump right into it. The Elastic Rope implementation that you've seen in my last devlog video was a cool idea, but unfortunately, it didn't work out quite as well as I hoped. As you can see, it's clunky and the rope physics were wonky. The worst part was that the hand wasn't actually grabbing the rope. I did mention that I would be fixing this in my previous devlog, but I figured it would be a bit too challenging to solve this problem with the current setup. In order to make this more responsive, my solution was to make everything faster. As you can see, with much quicker animations, the elastic rope seems more natural. Because the animation is happening so fast, I also don't need a solution like IK to realistically position the rope to the player's hand. However, this still doesn't solve the problem of bad rope physics. But just hold on, I've been tinkering a lot with various rope physics solutions in my other project, School Project. And guess what? With all the knowledge and experience I've gained, I came up with the following solution. First off, we have a couple of rigid bodies that are connected with joints. Except, as explained in one of my previous devlogs, when connecting rigid bodies together to create an elastic rope, they can be quite unstable. A workaround I found is to either change the physics fixed time steps or increase solver iterations. But both of these solutions come at a pretty hefty performance cost. Or, you can just have very few rigid bodies connected together. This will greatly reduce the chance of them going haywire and breaking. This, however, introduces another problem, which is that the lines are very jagged and stiff. We want some interpolation. Now, let's break this problem down in simple terms. Picture this. We have 4 points that need to be connected together using a line, but smoothly without any bumps. There's actually a perfect way to do this, which is by using a spline. Yeah, if you go on almost any image editor and use the pen tool, you'll notice how you can create curves. There's actually a much better spline that I can use for exactly my purpose. That is Catmull Roam spline. This is a super famous technique in computer graphics. Essentially, this type of spline will go through all the given points smoothly, making it perfect for accurately going through rigid body points. Best part? This spline formula is super fast, which is perfect for our situation. Oh, you're interested in knowing how this works? Well, let's say we want to connect 4 points using Catmull Roam spline interpolation. The first and the last control points of the spline will not actually be connected to the middle points. We'll see why in a moment. To find a point along the curve, we can plug in a value t into a mathematical formula. The formula calculates a new point at a t location that is influenced by the 2 adjacent points. In order to ensure there's no kink, the algorithm also considers the outer control points, which is why they aren't visible. At this point, you might also be wondering how this magical mathematical formula works. So, if a curve wants to pass through control points smoothly, it's important that it doesn't have a kink at those points. To achieve this, we need the incoming and outgoing tangents of a point to be the same. This is also known as C1 continuity. Now, this tangent is parallel to the directional vector between 2 adjacent points. Otherwise, the line may look weighted on one control point. Anyways, after the implementation, this is how it looks like. Looks much nicer. It was time for me to realize that the most important feature of my game, combat mechanics, is shit. This feature has been overlooked for far too long, even though it can make or break the enjoyable gaming experience. I have to admit, there were quite a lot of flaws in the system. The reason for these issues was probably because all the enemies were one shot. My original intention with this decision was because I wanted to make the gameplay fast with swift movements. This decision could have been fine, but I decided to add counterattacking, and this is where things started going weird. There was no point in counterattacking, as all enemies were one shot. Sure, there was a cooler animation playing, but that was about it. And then I went ahead and added combo attacks, which also didn't quite fit with the system I had created. Here's the thing, I made the classic mistake of adding random combat mechanics without considering how they would work together. When developing a game, you should always plan ahead, especially when it comes to a crucial system like combat. Lesson learned, it's time to take a step back and rethink the entire combat system. When it comes to developing a system, you first want to have a clear vision of elements you particularly want from it, without thinking of any technical limitations. In my case, it would be fast-paced action, freak movement, combo attacks, blade combat with more than one enemy, somewhat strategic, and etc. However, it's likely that there may be some elements that may not work together, like fast-paced action and combo attacks. Here's where I should make a trade-off. I'll have the enemy withstand more than one attack, but make the combo attacks faster to maintain the game's fast pace. To further develop the system, I removed counter-attacking and added an ability to block incoming attacks instead. This will not only make the combat feel more intense, but also strategic at the same time, especially when engaging in close combat with another blade-wielding enemy. More on that later. Now the most important thing to finalize the system is a bunch of testing and making sure that the combat is enjoyable as I planned. Here's where I definitely require some more enemies, since the drone enemies will just not cut it. A blade-wielding enemy had to be added, so I downloaded this model online. However, I couldn't find any pre-made animations of enemy attacking, blocking, or moving, so I took matters into my own hands and decided to create the animations myself. I'm not sure about you guys, but I personally cannot work on the mechanics if I don't have the animations ready. Creating the animations took a while, but it was worth it. Hopefully. Instead of manually coding the enemy's behavior, I decided this time to train it using AI. Mostly because I couldn't be bothered. I figured an AI trained enemy would be more player-like and unpredictable, making the fight more interesting. Machine learning in Unity is actually quite easy with the help of a package called Unity ML Agents Toolkit. This toolkit has all the necessary training implementations already done, so all I need to do is just make a bunch of methods that will control the character, and the trained AI brain will take over and call these methods appropriately. Now the training can be done just by simply pressing the play button while the trainer is attached to the Unity editor. Sounds quite simple, right? Well, the harder part was actually training the AI properly. Quick pause. For the training setup, I decided to put two AIs fighting together instead of a player because I can't be fighting the AI the whole time they're training. To ensure the AI receives accurate combat details, I have something called Combat Handler that's also attached to the player, so I shouldn't have problems with the trained data with the actual player, hopefully. First, I did some reinforcement learning, which is essentially trial and error. The AI's brain tries a bunch of random stuff until they get a reward, which we'll talk about in a moment. But if an AI receives a positive reward, it will continue to make that action. If they get a negative reward, they will prevent making that decision. Now when I first started training my AI models, I read online that they should receive a reward of 1 if they manage to complete their task and -1 reward if they fail. But after a few hours of training, I noticed that my AI models weren't really making progress. Their movements were jittery and it really didn't seem like the AIs were progressing, like they were barely landing hits on each other. So I tried a slightly different approach. I decided to take away a small reward every time they make a jittery movement and give them a small reward when they moved forward. I thought this would encourage them to keep moving and avoid making shaky movements. But guess what? This was a horrible idea. You really shouldn't be doing this when you're training an AI. What happened was that the AIs didn't rotate at all to prevent getting their rewards taken away, and they also kept moving forward and falling off the platform because they were able to get more rewards by doing so. You could say they sort of found an exploit. Then I actually started looking up about how I should be training my AIs, and I realized I definitely shouldn't be doing this for the reasons I've mentioned earlier. I then found out something about imitation learning. This method involves recording demos that serve as a guide for the AI to follow. By using these demos as a reference, the AI is able to mimic the actions performed in the demos, which significantly accelerated and stabilized the learning process. After performing imitation learning, I was finally able to witness the AI fighting together. Of course, there were still some tweaks I needed to make, such as tweaking hyperparameters and various other configurations, until I had everything just right. Although, I still feel there's more to be done in terms of training and configuration adjustments. Additionally, I would also like to see a 2v1 against a player in the most optimal formation possible. This is actually the reason why I didn't decide to code the AI on my own, because, as I said, I couldn't be bothered to code the cooperative behavior between the AIs. Definitely stay tuned for AI updates. There are also other changes that have been made to Project Terminal. Things like camera jitter fixes, better camera effects, some map progress, and so on. I think it's slowly coming to a point where almost all of the sort of core mechanics of the game have been implemented. I should be focusing more on developing the actual content of the game now. This has been Semicoder. I kind of know how to code.